All right, you guys, today we are taking on the reflection. So just a reminder that we're looking at this broad category of rigid transformations. So a rigid transformation, we are transforming a figure, altering place and position, but preserving size and shape. So the original figure, the pre-image, and the resulting figure, the image, are congruent. And we have three types of rigid transformations. We have the translation that we've already covered. Today we're tackling the reflection. And in the next few days, we're going to tackle the rotation as well. So they're all rigid transformations because while we are altering the place and position, the figures are still remaining perfectly identical. They are staying congruent. So first up, I have my reflection. So the reflection is a type of rigid transformation where each point moves the same distance across a mirror line. So if I take my ruler, let me take my ruler, my straight edge, and if I connect the R's, for example, connect the A's, for example, and the T's, for example, we should be able to see that right here is our mirror line. Let me just draw an arrow to it. And each point, so R, that pre-image point, the distance to the mirror line is staying the same in the opposite direction. So the distance here to here matches the distance here to here. Same thing for the A's. So A to the mirror line will be the same as the mirror line to A prime. T to the mirror line will be the same as the mirror line to T prime. Okay, one other thing that you should notice is that if I made a segment here from R to R prime, A to A prime, T to T prime, that mirror line is really the perpendicular bisector of each of those three segments. So we should see from the visual that the mirror line specifically is perpendicular. So perpendicular with R to R prime, that segment, A to A prime, that segment, and T to T prime, that segment. So it's running perpendicular to each of those, okay? And technically, it's the perpendicular bisector of each of those segments. So I could add that too. So perpendicular bisector of each of those segments. All right, next up, we're going to get through a few examples. So here what I've done is I've pre-graphed my figure. So we're calling it triangle cow, C-O-W. So I'm telling you what the vertices are. So 2, 0, 4, 3, and 6, -5. Those are all of the coordinates for the triangle. All right, so for the first one I'm saying, well, the mirror line is at x equals -1. So the mirror line, we know that that is a vertical line. Because it's x equals a constant. So if I go to where x equals -1, and I draw in that mirror line right here, this is the line that my figure has to reflect over. Let me zoom in really tight so you guys can see this more clearly. All right, so if I start with the one on top, so if I start with O, I need to count over to the mirror line. 1, 2, 3, 4, 5 units. So I need to go 5 units in the opposite direction. 1, 2, 3, 4, and 5 right here. Here's going to be my O prime. C, we are 1, 2, 3 away. So 1, 2, 3 away in the opposite direction. Here's my C prime. Okay, W, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Here's my W prime. Okay, I'm going to take my straight edge and connect the dots. And then here is my resulting figure. So this is my image, and I can tell using all of those prime notation. So each of those apostrophe looking things, they read as prime. So this is my before, this is my after, this is my pre-image, this is my image. So my figure should still be perfectly congruent. We've just reflected across that mirror line. Okay, I can also just double check if I use my ruler. Am I seeing that here that pathway that connects the O's is perpendicular to that vertical mirror line? Right, I can see that pretty easily because all of those are horizontal pathways. Okay, for the next one, let me slide it over. Here I'm saying that the mirror line is y equals 3, so we should recognize that that is a horizontal line. Because it's y equals a constant. So I'm going to graph my mirror line at y equals 3. So right here it's going to pass through where point O is. All right, so there is my mirror line. So point O really isn't moving anywhere. So I'm just going to put a new little dot there and just write that that's going to be O prime. For C, I need to count up to the line. So 1, 2, 3. So 3 away in the opposite direction. Here's my C prime. And then W is the last one. So 1, 2, 3, 4, 5, 6, 7, 8. So I need to go 1, 2, 3, 4, 5, 6, 7, and 8 right there. There's my W prime. Okay, connect the dots. And then here is my resulting figure. So a perfect reflection across my mirror line at y equals 3. So again, my figure should be perfectly congruent to the first. We've just reflected across that mirror line. And if I connect the C's, the O's, and the W's, right, we should be a perpendicular pathway with the mirror line, which makes sense because our mirror line was horizontal. All of these pathways would be vertical. All right, next one. So here my mirror line is y equals x. So that is the easiest line that we can graph because it's in slope-intercept form. It's saying that the slope is just 1 and the y-intercept is at the origin, 0, 0. So I start at the origin, up 1, right 1, up 1, right 1. So I'm just giving myself a few points to make a nice straight line at y equals x. All right, so here is my line, y equals x. And then how do I reflect it? So we're going to show you a rule in just a moment, but before we do that, I just want to give you kind of this workaround. What is a way that we can do it without being dependent on a rule? So if I'm reflecting over this line, what I want to think is I'm going to go point to point. So if I'm looking at O and I'm reflecting over this line, what I'm going up to get to the line is what I need to go over to go across it. So whatever I'm going vertical, I need to do horizontal for the other one and vice versa. So I'm just going to say that horizontal needs to convert to the vertical when you're going across the line. Let me write that. So horizontal to vertical or vertical to horizontal. Okay, so if I'm going 1 point at a time, let's say that I start with the O. So let's say that I go up. So if I go up 1, that means I gotta go left 1 in the opposite direction. So right here would be my O prime. If instead I had gone horizontal to the line, left, that would have made me go up instead. Okay, let's look at the C. Let's say for C, I go up 2. That means I have to go left 2 right here. So here would be my new C, my C prime. And then I need my W last. So my W, let's say that I count left. So if I go left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means I have to go up 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here's my 11. W prime. All right, so then when I connect my dots, I want to see if this looks like a true reflection. Okay, and then that looks pretty good. So remember that I could always connect the O's and show that it's a perpendicular pathway. Remember that the mirror line is a perpendicular bisector of this segment right here. If I do the same thing with my C's, right, I'm seeing that same relationship. And if I do it with the W's, right, I'm seeing the same exact thing. Okay, if I show you what's the rule, let's say that we focus on one of the 3 coordinates. Let's say that I look at point O, for example. So point O was originally at 4, 3. When it got reflected over y equals x, where did it flip to? It flipped to 3, 4. So O prime was 3, 4. So if I want to give myself a shortcut, what is my rule? I can say, well, x, y, arrow to the right. Well, what's happened? The x and y values just flipped positions. So y, x. So here is my rule. So we're saying, okay, here's my original points, and we're literally just flipping their position. So again, if I'm doing it without a rule, I'm really counting to the line. If I'm counting horizontally, then I'm counting vertically on the opposite side. If I started off vertical, then on the other side, I'm counting vertical. I'm sorry, if I start out vertical, on the other side, I'm finishing up horizontal. So it goes with the opposite one. So horizontal goes to vertical, vertical goes to horizontal. All right, last variation here. So mirror line is y equals negative x. Okay, so in slope-intercept form, that means that we start at the origin, and our slope is -1. So down 1, right 1, down 1, right 1, and so forth. Let me draw it in bright red. Just like that. So here I usually label it y equals -x. All right, so there's my mirror line, and I'm going to do the same process to reflect across it. So we know that horizontal goes with vertical and vice versa. So let's say that we start with the O this time. So here if I count horizontal, 1, 2, 3, 4, 5, 6, 7. Well, now I'm going to count vertical, right? I'm going to go down 7. 1, 2, 3, 4, 5, 6, and 7. So here's my new O prime. Okay, for C, let's say that I start down. Down 2 means left 2 in the other side. So right here is my C prime. Okay, for W, let's say I count down and then left. Right here would be the W prime. Okay, connect the dots. Make sure it still looks like that red line is a true mirror line. And it does, right? It looks beautiful. It looks beautiful. So if I connect the W's, for example, again, I can see that they're running perpendicular with the mirror line. Same with the C's and same with the O's. Okay, so if I come up with a rule, let's say that I look at the O's again. So O started off as 4, 3. What did it become when it reflected over y equals negative x? So we see it right here. It's negative 3, negative 4. So as a rule, let me stare at that for a second. What has changed? Well, the x and the y, they've switched position and they've both taken a negative. So our rule here would be negative y, negative x. All right, let me flip over or go to the second sheet right here. All right, so here I'm giving you a triangle FOX. It's graphed. I want to graph its image after the reflection described. So here we're saying, well, now reflect it over one of the two axes. Let's start with the x-axis. So remember, here is the x-axis and here is the y-axis. So if we're saying across the x-axis, we're saying, well, this is your mirror line right here, the x-axis. Okay, the x-axis as an equation, right, would be y equals 0, right, if I wrote it as an actual equation. All right, so now I want to reflect over the x-axis. So I'm doing the same thing. I'm going to count to the line and do the same thing in the opposite direction. So here I'm 3 away, so I need to be 3 away in the opposite direction. So here's my F prime. O is 6 away, so I need to be 6 away in the opposite direction. So right here, O prime. And X is 2 away, so 2 away in the opposite direction puts me right here. Here's my X prime. And then I can connect my dots. And then here is my resulting figure. This is my resulting image. Okay, if I try to think about that as a rule, let's say that I look at one of my points. Let's say I look at F. F was negative 1, 3. What did it become? It became negative 1, negative 3. So I can see that my y values switched the opposite sign. So if I want to think about this as a rule, I can say xy, arrow to the right. The x coordinate stays the same, but the y switches to the opposite sign. So there's my rule for reflecting across the x-axis. And one thing that I like to think of is, well, what stayed behind? What changed? So the x stayed behind as is, the y changed. So if I cover up, reminds me that I'm reflecting over the x-axis. Okay, a similar one right next to it. Now we're reflecting across the y-axis. So across the y-axis, again, here is my x-axis, here's my y-axis. So my y-axis is my mirror line. As an equation, it would be x equals 0. And I'm doing the same thing. I'm just reflecting over the line. So I'm going to count my O first. O, we are 4 away from the line, so I need to be 4 away in the opposite direction. So here's my O prime. F, we're 1 away from the line, so 1 opposite. Here's my F prime. Okay, W is 7 away from the line, so 7 away in the opposite direction puts me right here. There's my W prime. Okay, I'm going to go ahead and connect my dots. And there we go. There is our resulting figure. So again, if I wanted to make a rule out of it, let's say that I focus on the f's again. F was originally a -1, 3. And where did it go to? Well, it became 1, 3 instead. So we can see that in this case, it's the x value that is switching to the opposite sign, but the y that stays the same. So as a rule, xy, arrow to the right, we're going to say -x, comma, y. All right, next, let me zoom out a smidge. Here I'm giving you just an overview of all of your transformations that are reflections. So all the ones that we're going to do in this class, we are reflecting over the x-axis. I'll get a little tighter. So over the x-axis, that's what we just saw. So when we reflect over the x-axis, the x stays the same, but the y switches to the opposite sign. Okay, that's what we saw right up here. Okay, when we reflect across the y-axis, it's the x that switches to the opposite sign, but the y that stays the same. That's what we saw right over here. Okay, when we're reflecting across y equals x, the x and y switch positions. And when we reflect across y equals -x, they switch positions and they switch to the opposite sign as well. All right, last thing that we have to do is go over a glide reflection. So a glide reflection, first, is a composition of transformations. And that just means that we're going to do back-to-back transformations. Okay, it ends up being, in sequence, a translation followed by a reflection, or vice versa, a reflection followed by a translation. Okay, and the one thing that you have to really keep centered on is that to make it a glide reflection, it's not just a translation paired with a reflection. We also need to make sure that the pathway of the translation is parallel to the mirror line. So a classic example is footprints. So over here, I picked an image. It didn't translate so well, but I think that you guys get the idea that this is essentially looking at footprints in the sand. Okay, so you could visualize it as this foot slides up and then reflects into this position, or I could picture it as this foot reflects here and slides up into the next position. So let me just draw it a little bit more simple. Here's my mirror line. Let me make a nice little foot shape, kind of like that. And then the foot right here, like that. So I can picture that it's sliding up, flipping over, or I can picture it flipping over and sliding up. It ends in that position, and that motion that's going forward, right, however we're sliding it forward, should run parallel with the mirror line right here. All right, so let's do one example, and I'll zoom in a little tighter as well. So I've given you the starting figure, right? I'm calling it triangle RAT. It's already plotted, and I'm saying graph its image after the glide reflection. So we're going to start with the translation. So I'll mark that as number 1, and it's saying x, y minus 6. So it's saying slide it 6 units down. So let's first slide it 6 units down. So 1, 2, 3, 4, 5, 6. Here's my A prime. Okay, T is going to come down and join it. Here's my T prime. And then R, 1, 2, 3, 4, 5, and 6. So here's my R prime. Let me connect my dots. So here, here, and here. All right, so I've done the translation first, and we can see that every point, right, slid down 6 units. So now we have to build off of that and do the reflection next. So when I look at the rule, I see a -x, y. So that tells me that since the X is changing to the opposite sign, covered up, the Y stays behind, that tells me that it's a reflection over the Y-axis. Okay, so let me mark the Y-axis. So a reminder that here is X and here is Y. So here is my Y-axis, and I want to flip over it. So I build off of right here. So I build off of the prime notation, so the first image. So I'm going to flip over to here. So here will be my new R double prime, because it's the second stage. Let me get an even tighter. I know it's hard to see all these points. Okay, for the A, here we are 6 away, so I want to be 6 away in the opposite direction. So right here, this is my A double prime. So again, it's my second stage in the composition. Right, now we've already said that it's going to be a glide reflection. Still want to talk about Y. In the T, we are 3 away. So 3 away in the opposite direction. Here's my T double prime. Okay, connect the dots. Okay, and we should see our resulting figure. So again, I just want to circle back to what makes it a glide reflection. Okay, we absolutely see that it is back-to-back, a translation followed by a reflection. So that's the first criteria. So translation, then reflection. And then I'm also looking for, is the translation pathway parallel to the mirror line? So let's say that I draw in all of those vectors from my original pre-image to that first image. So here, let me draw that in. So if I draw in R to R prime, T to T prime, and A to A prime. And let me zoom out a smidge so you can see everything that I'm writing. All right, so we've said, is it a glide reflection? We already know it is, but why is it? So first, a translation followed by a reflection. It could be vice versa as well. Okay, but we're saying exactly as we see it. And then the second criteria is the pathway of the translation parallel to the mirror line. Well, absolutely, because our pathway for the translation is a vertical pathway, just like the y-axis right here is a vertical pathway. Right? If we were to write this equation, this line here would have an equation of x equals 0. So I'm going to add that last detail, that the translation pathway is running parallel to the mirror line. All right, and that's what I got for today. So a nice little intro to reflections. Have a good rest of your day.